Hi, I'm going to be looking at this muting relay circuit yet again just before I assemble the PCB, which is on its way. Greetings, the Astro 30 here yet again, and I'm looking at this ETI-480 power supply muting relay de-thump circuit that was published in the 1977 issue in March of the ETI magazine, or Electronics Today International. I just want to go through and make sure that I've got all my math correct. I didn't measure any voltages in the last video, which is the wrong thing to do. So I just want to make sure, because the calculations for the resistor I was getting made that transistor get very, very hot. So either my math is wrong or something else is going on. So that's what I've got to investigate. Well, after 12 hours the board is well into production. It's 31% currently. The part that it's up to is the circuit, which is doing the outer layers, both front and back, so that's what they're up to now. Well, it seems to me that I was wrong. There's more like 37 volt after DC rectification and filtration with that half-wave rectifier, which is that diode there and that capacitor. That's between that and zero, so that's almost close to what the DC voltage is on the power supply. I mean, it's close to it. I mean, that's 42 volt at the VCC line, so there's still 37 volt at the half wave rectification point. And I found to control what temperature this transistor is getting at is to slightly increase. I mean, that's still getting hot, but I've now increased the series resistance there on the emitter to 470 plus 220. That's what, 690, and measuring across the relay coil is 8 volts, so it's just barely enough to turn it on. Very, very interesting. So that means my math was wrong. So with our VDD voltage of 37 volt minus the relay coil voltage, that equals now 25 volt. And to work out our resistor, we now need to divide that by the current, which is around about 44 mA. Yeah, it needs to be closer to 568 ohms. So it does actually pay to measure what the voltage is here first, rather than just assume, because you know what they say about assuming, it makes an ass out of you and me. So okay, that transistor is still quite hot to the touch, but not as hot. So the formula is correct. My math was wrong. However, it doesn't mean to say that I have to modify the layout in any way. So that's good. I'm going to call it now and say that the transistor you should use is a BC546, not a BC548. Well, not at plus minus 42 volt DC. That is a 30 0 volt 30 transformer, because the 548 has a maximum collector emitter voltage of 30 volts, I believe it is. So there's 37 volts on the VDD line, so you're really pushing the limits of that transistor to the point where it could fail. Admittedly, when ETI designed this in the 70s, it was really only designed for a maximum supply rail of 40 volts, but then again, that is still putting that transistor at its maximum limits. If, say, we had 40 volts here and we had 35 volts here, yeah, that's still exceeding the limits of that transistor. So we're going outside the SOA curve, or the safe operating area, which is to do with the junction temperature of this transistor between the base and collector, plus whatever voltage and current is flowing through the collector emitter junctions. That can really limit the life of the transistor and destroy it really quickly. So yeah, I would not use a BC-548. Meters jumped up to 8.22 volt, which is just enough to make the relay still stay engaged. I'm going to call it that because that's mildly warm. It's not overly hot. So yeah, BC-546 it is, not a BC-548. And also make sure to do the correct math for this resistor, or else yeah, you could be exceeding limits. That 470 is getting quite hot too. Transistor's not too bad, but it is hot to the touch. However, the other thing to consider is these are a multi-tap transformer. I could reduce the overall voltage going in to the power supply, which in turn should reduce the amount of heat going on that transistor, maybe, theoretically. I don't think it's going to make any difference. But the secondaries on this are capable of 15 and 12, so if you add 15 and 12 together, that gives you 27. So after rectification and smoothing, that gives us roughly 38 volt plus minus, which is only probably 5 volts smaller than what it is currently. The other reason for the change is I got given these capacitors a while ago, actually a couple of years ago, by Danish Dart. They're 15,000 microfarad capacitors at 50 volt. I've got 2 of them, and it's one of those style, but it's been pulled off of something. Not sure what, probably an amplifier. I want to actually use it in my power supply to save me having to buy 2 new capacitors, because the 10,000, which is what the circuit is designed for, at 63 volt, we're looking at around about $8–9 a capacitor. I could get them on Amazon for a pack of 4 of them for around about the 23 mark, so that makes them around about the 5–6 mark. But still, there's the time involved of, you know, waiting for them. These capacitors are probably perfectly alright, so I don't see any reason why I can't use them as the main filters. But if I leave the transformer in its current configuration of 42 plus minus, that only leaves us 8 volt from the maximum rating. And my personal experience with capacitors, I had a 25 volt, I think it was 1000 microfarad capacitor, going across a DC supply of 23.4 volt, I think. So I was only 1.5 volt within the safety margin, and they blew up. And these are pretty big capacitors, and I don't want to have the same repeat, because these will go off with quite a bit of noise as well as shrapnel everywhere. So I'd rather lower the voltage of the transformers down to the 38, so, well, 27 on the AC side and 38 on the DC side. So that leaves us, what's that, about 12 volts before the maximum. That means the amplifier will produce a little less power, but it's a bit of a more safety margin there. And as for this power supply sitting on the desk here, don't worry, I will find a use for it one day. It's always handy to have a linear bipolar supply sitting around that can operate unregulated on various different voltages. So that's fine. That can be a good test power supply for things. Don't know yet, I'll find a use for it. And the next thing I want to check before I continue on is I want to check if the dropper resistor that I've got on my circuit here is good enough to power this LED in this switch. Now this switch is JCAR catalog SP0706, and according to the information I've got on the website, it's 240 volt 1.5 amp with a requirement of 2 volt for the LED, so there's no dropper resistor for the LED inside the switch. So the dropper resistor has to be on my power supply. And I originally thought that this switch would not actually work for my application. When I did the calculation for the VA of the transformer versus the voltage input, which is 240 volt, it came out to about 0.6 of an amp, so 600 milliamp, and because there's 2 of the transformers, that's going to be 1.2 amps. That switch is rated at 1.5 amps on 240 volts, so it's just barely capable. So then I decided to look at the data sheet that JCar provided for this said switch, and the data sheet is absolutely useless. This is mostly just engineering data of how the switch is assembled. It doesn't tell you any information about the LED, it doesn't tell you any information that's quite important of what the current draw of the LED is. So I'm going to assume, for all intents and purposes, a 5mm standard LED that draws around 20 milliamps at 2 volt. Because I know that the VDD line at the maximum 30 volt transformer is going to be 37 volts and the maximum forward voltage of the LED is 2 volts, I know that's going to be a total of 35 volts. So it's the VDD minus the LED voltage, which is 37 minus 2, which is 35, divided by the desired current of the LED, which is 20 mA. That comes out to a resistor value of 1.75K. I've got a 2.2K resistor there on that board, so that should just be about right. So the next thing I'm going to do is I'm going to test the brightness of the LED on that switch with my current configuration of the circuit and see if it's satisfactory enough. Hopefully I don't blow it, because these switches are worth $7.50 each. Okay, so for this test all I need is access to the secondary winding of the transformer. I've got the power supply not in the circuit because I'm not really worried about the rest of the circuit. All I'm worried about is the half-wave rectifier, the filter capacitor and the LED. I've also got a meter sitting there in the background which is going to be measuring the voltage coming off that half-wave rectifier capacitor combination. Okay, so I'm going to plug it in and hopefully that LED doesn't go bye-bye. It is actually lit up, so that's good. According to the meter, I've actually got a good 40.1 DC volts across that half-wave rectifier capacitor combination, but with the light off, that is actually illuminating and lit up pretty good. So I'm going to say that that's going to be good. It is only just a panel indication that the power supply is turned on, so for all intents and purposes that works absolutely perfectly. The LED seems to be happy and I'm happy. As for that voltage measurement, it is subject to different circuit conditions including loading. Because the power supply is not actually connected up, that's what I'm getting. All I need to do now is test one more thing and we can move on to assembling actually a PCB. And I'll leave this in a bit of darkness here. The PCB has actually been manufactured and has been shipped. It only took around about 30 hours turnaround time with PCBway to actually manufacture the thing, which is astoundingly good because they did say it was between 3 to 4 days. I'm quite happy. But now I'm going to move on to the next thing that I want to test. Brian says, ugh. So I've received a relay in them. I've received a relay in the post. It's an OMROM relay, which is the relay I want to use on that PSU. Unfortunately, I'll just get it out of the bag. So, there's a problem. It's the wrong footprint. This is a DP-DT footprint. This is an SPDT relay, but it's using a DP-DT footprint. That's the Panasonic one. As we can see, they're not the same. There's 3 extra pins. The thing is, what they've done is, in a DP-DT OMROM relay, you've got one set of contacts on this side and the other set of contacts on the other side. They've actually physically joined the contacts together. So here, here and here. That just increases the current because this is actually capable of handling 16 amps, both DC at 30 volt and AC at 250 volt on the contacts. So I can't really use it. Well, I can, but I'd probably have to cut off a few pins to make it look like that one. The reason I got this relay is because this one doesn't make a very loud audible click. Well, it's very quiet. This is the one I wanted to use in the first place. Now, without making this video too long and boring, but it is kind of important that these points are addressed before the final PCB is assembled, because the last thing we want to do is damage expensive components and also ruin a PCB, which for all intents and purposes to me, even though I got a quantity of 5 of them, is quite expensive to have manufactured. I've written a list of muting relay plus PSU modifications. Now the first change would be the BC-548 is changed to a BC-546 because it has a higher collector emitter voltage. Remember that VDD line had roughly 37 volt DC on it, which is exceeding the limitations of the BC-548, which has a emitter collector voltage rating of 30 volt. The other point is, I've already mentioned, is to reduce the input voltage to 27027, that's plus minus 38 volt, which read the next point. Use those two 15,000 microfarad 50 volt capacitors as filters, so the voltage needs to be lowered so I'm at least within, 10 volts of its maximum rating. Very important is to measure the VDD line before installing the 47 ohm resistor, so the PCB can be assembled up to the point where the 470 ohm and the relay get installed, and you can leave both out. Read the next point. Calculate the correct value for the 470 ohm resistor using the equation I just said before. The other thing is, I'm going to change the relay to an Omron 12 volt SBDT relay as just previously stated. Next point is to test. Well, yeah. And final PCB assembly. Well, it's a little bit hard to test when I haven't done the final PCB assembly. So reverse those two around. But that's it. Let's get on with something more constructive. Oh, I see what I meant here with test. Yeah, it was for the previous point. Change the relay to an Omron 12 volt SBDT relay and calculate the correct value for the 470 ohm resistor, and then test it to make sure that the relay is going to work with the circuit. Then do final PCB assembly. Yeah, that makes more sense now. I couldn't remember last night why I wrote that way round. Now I remember. Well, great day. My PCBs have arrived. Not sure exactly which PCBs, but I'm about to find out. I'll just grab something to open the box with. Let's see if I can figure out how to open a box. Maybe, maybe not. Let's see, I'll need to probably cut it there. Cut it there. Like so. There we go. Ooh. Oh, these look frickin' awesome. Oh, look at that. Nicely packaged. Oh. Alright. Find my sharp knife. I'll get rid of this sealed moulding thingy. See if I can actually extract the circuit boards from packaging without scratching the PCBs with a knife, of course. Getting close. Oh man, slightly bigger than I thought they were going to be. But then again, all measurements relative. Oh man, check that out. That is so freaking sexy. Oh, nicely produced. Oh, I'm in love with that now. Oh. Right. Put these ones to the side because we don't need to have them out at the moment. It doesn't feel warped to me. That is so sexy. Huh. Now I need to verify parts actually fit on the board. That might be a good start, wouldn't it? Take this 12 volt relay. Yeah, that fits in there nicely. Not that I'm using that one, but
That is awesome. Alright, now as for my full bridge rectifier, when I can get it out of the packet, that goes that way. Take a little tiny bit of effort, but yeah, it goes in there. Oh, okay, so I've won with that. Now for my choice of capacitors. I've just got one for now. Let's see. Yep, like a glove. Right, well I'm happy that all my measurements worked out. Now I suppose it's time to get around to building it, but I need to just check these last connectors here to make sure they fit wherever I've done with the bastards. I actually don't know what I've done with the bastards. Where have I put the bastards? Well, that took longer than necessary. It took me about 20 minutes to find the things because I couldn't remember where I put them, but anyway I found them now. And they fit in the board just nicely, and it doesn't cover the text too badly. Sweet. I am ecstatically happy here. So now, I guess it's time for assembly of this. Yay. Alright, it's been a long time coming, about 2 weeks, but I've got most of the parts. I'm missing the 10k 1 watt resistors, I forgot to buy them. I'm also missing the spade terminal that goes here, so I'm going to have to go buy them. That's another $6 I don't need to spend this week. Anyhow, I've got all the connectors, the transistor, the capacitors, and the diodes. I can start with the resistors, I suppose. There's only 2 low profile ones. That one is the 2K2, that one is the 47K, so I need to straighten them out after they've been through breadboard. I've got some leftover solder from a kit here I'm going to use, so I've got to figure out how wide it needs to be. I reckon about that. I'll soon find out. So, put it the same way around as the text. This makes readability easier. Let's see how good these boards are to solder to. So, okay, let's see. Seem alright. Yeah, flowed through to the other side nicely. It's pretty nice. Sweet. Now I'm not going to film too much of the assembly process because it's going to be pretty boring. I reckon it should only take about a total time of 15 minutes to assemble this. So I'll just put the 2K2 in and I will move on from there. Because I'll have to go get those other parts. The only resistor I'm not going to install is this 470 ohm yet, because I want to make sure that I have got the correct resistance there. I was just checking which way the bands were. It was kind of confusing because the red often looks like the brown. There's 2 browns and 2 reds. After all these years they haven't fixed up their color code bands and separated the brown a little more from the numbers, so we know which end is the tolerance. That didn't solder at all. Yeah, it did. Okay, it's the 2K2 in. Trim off the junk. Sweet. Getting there slowly, just doing these little JST connectors. I've got the capacitors in, 2 resistors, the 2 diodes and the transistor so far. So I'm just trying to put these little connectors in. I probably was a bit preemptive with the doing the smaller capacitors first. So I've got to try and prop that up somehow. Solder at least one end in. I'll just tack it so I can move it. There we go. Make sure that's perfectly straight. Yeah, that's good enough. Put this one in. Do the same thing. Side cutters are very useful for a lot of things other than cutting things. They make a great prop. That one's crooked to hell. And it's straight now, I can solder it properly, so that's what I'll do. Really wish I had a assembly jig, which I don't have. It's kind of annoying. But, yeah, well, it is what it is. Okay. Them two are now soldered in. It's starting to look like a circuit board now. Yay! Alright. I'm going to leave the 4-way one off for now because I'm not going to connect it, but I'll put these 2-way ones in, which I believe are taller than the capacitors, so that makes life a little bit easier. Oops. This board's nice to solder to, I must admit. It's very easy. I'm actually quite pleased with the quality, even though there was cheap boards. Well, I say cheap, but it is kind of expensive. It cost me like $60 Australian to have 5 made and shipped. So that is quite expensive. But for what I paid, the quality is awesome. And it's not warping too bad as I'm soldering to it. So that's always a good thing. Well, now I guess I can put the bridge rectifier in. Make sure I do get that the correct way around. Positives over that way. Just so that part is out of the way. Doesn't have to be perfectly proud with the board, just as long as it's in there. What I might do is I might leave the 2 AC connection leads long so I can actually clip leads to it, so I can connect the transformer up to it easier for testing. You'll see what I mean a little later after I finish assembling this thing. But I'll cut off the positive and negative ends because they don't need to be that long. So, cut that one off. Oh. Cut that one off. Oh. And if I carefully bend them with a pair of pliers over a bit so they don't short on each other, and I connect the clip leads, and then I can cut them off later, if you see what I mean. So, I just need to touch up these joints where I cut. A bit better. I hate when that happens. Solder balls. That's a bit better. Okay. Solder mask is, yeah. So anyway, that's the bridge rectifier in, and well, this is pretty much its complete assembly, because I can't really go any further now because I don't have the resistors or my ground connection, although I can probably pop the relay in. So I'll put that to the side. I'll grab my relay that I'm going to use. I'm going to prep it I mean, it cost me, yeah, $9, but whatever. So if I put the two relays side by side so I know which pins I'm cutting, and I've just realised it's not even the same footprint. They're wider. Wow. Yeah, they're wider. Shit. Well, okay. Saves destroying it, so I'll just use this one then. Got not much real choice. At least I know it fits. Okay. It's almost the same height as the bridge rectifier. Yeah. How lovely. Lovely. I could probably put the filter caps in now, I guess. But that relay's in, it's permanent. That's the relay I'm going with. Now, I was going to say something, but I can't remember what it was. So, with the these larger resistors here, they're going to be mounted slightly proud of the boards to help with heat dissipation, so you're not scorching the board. Anyway, to the filter caps, which is the largest of the components. Pop them in. Oh. Thanks Danish Dart, I've got a use for these caps now. Hopefully they work, because I don't really want to have to pull them back off the board. It'd be annoying if I have to do so. Okay, the capacitors are in. Oh, got some weight to it now. That is awesome. With the other connector, which I'll solder in last, and the other three resistors, that board is almost complete. That turned out pretty awesome. I can actually test right now, because these two resistors that are missing are only the bleed off resistors for the capacitors, but I can test my voltage input. Getting the ground, it would help if I had that connector. So I might hold off testing and measuring voltages around the circuit to make sure everything's functioning correctly and it's not going to go off with a bang. I might leave that until I've actually got the connectors. So that should be negative on that side. Yes, it is. Okay, I've got the caps the right way around. That was all I was checking. Okay. Alright, well, yeah, moving on. The next thing I should do before I f*** off to JCar and spend some more money is check that I can actually get my screws through the holes. And put some PCB standoffs on it. Not that they're going to serve much purpose with these long ass leads on it, but that's yeah, okay. The idea with this is I would screw the standoffs on the PCB first, put it inside the speaker box through the bass driver hole, and then put the screws in from the outside to tighten it down, with washers of course. Yeah, that connect ended up a bit crooked. Anyway, I want to see if there's any DC voltage on the output wherever I've done with my meter. For some reason, when I put this on voltage AC and put it across a DC circuit, it doesn't measure anything, which is odd. So I'll put it across negative there and positive here. This bugger all, it's about 291 millivolts. So there is probably a little bit of a charge on those capacitors, not much of one. Cool. Now to go spend some more money. I must have spent at least $100 at JCar this week. Right, I got the missing parts I needed. The only issue I had, well, mechanical issue, was the spade terminal. The holes are very tight because I didn't have the spade terminals to actually measure what the pitch was. well, not the pitch, but the diameter of the hole I needed. So I had to use a pair of pliers to just gently squeeze it in. So I've got that in, and I'm now just soldering in the two 10K discharge resistors. And we're almost ready for testing. That's the plan anyway. See, look at that. How sexy does that look? Oh. Now, before I run it on the AC, it might be a good idea to use my 19 volt plug pack that's powering the soldering iron to put across the AC terminals here on the supply, just to give these capacitors, because I don't know how long they've been sitting around for, a gentle charge, just to, you know, make sure that they're functioning correctly and they're not going to be like a dead short or something. So that's what I'm going to do now, but I'm going to have to pop you on the floor for that, because the last thing I want is for these capacitors to go off with a bang, and they will be loud. So nothing unusual. I'll just measure VC positive. Oops. I'll get my big fat hand out of the way. Got 7 odd volt there on the negative, got 7 odd volt there, so yes, the supply is working. Okay, now what's my VDD line doing? Well, probably nothing. It's about 8 volt. Okay, I think I'm ready to hook it up to the transformers. Fuck, I got the transformers wired up right now. It's 24 volt windings, 2 of them, and I'm just going to test it first before hooking into the circuit and make sure I've got the wires the right way around and it's in phase. Being 24-25 volt, I'm looking for about 50 volt AC on the meter. So I'll plug it in. Yeah, we got 50 volt AC there, so we are wired correctly. Alright, we're ready to plug it into AC, and I'll just verify the voltages at the output. Hopefully nothing goes off with a bang. Let's try it. Always nervous at first. Right, so on the positive DC, got 34 volt, not bad. On the negative DC, negative 34 volt. Should also have DC on this other connector. Yep. Beauty. Right, now what's our VDD line, which is off of the half-wave rectifier here. Okay, 34 volts AC, so I'll just unplug that. So, R equals the VDD, so I'm going to say 35 is a round figure, minus the voltage of our relay coil, equals that, divided by the current draw, which is, if I remember correctly, 0.44. Yeah, you're looking at roughly a 520 ohm to be exact. I've only got a 470, but it should be okay, so I'll just leave it as 470 for now, and if I want to I can change it later. Okay, 470 ohm resistor is in. Now I'm just going to test that the relay works, which it should. There it goes. I'd never tested what voltage was coming out of my LED port, so I might just do that now. 29 volt, okay, fair enough. Because I've made the executive decision now that I'm going to be running the power supply off of a 24 volt supply, or 48 volt total AC. And yeah, it'll lower the wattage of the amplifier, but yeah, that's okay. But no, the circuit is working. It's working as expected. It's routed correctly, and I'm happy. And it looks absolutely sexy when it's fully populated. I mean, you gotta admit that is pretty sexy. The only issue, as I said, I had was with that spade connector down there. The holes are a little bit tight and a bit too small. Should have probably made them drill them out to 1.2mm, would have been probably better, but you can squeeze it in. Another thing you could do with these is you could just take a small file to the edge of the
display terminal where it connects to the board and just file it down. Actually, some are big, some are small. I've noticed some are fatter than the others. Or is that because they're upside down? It's hard to tell. Anyway, I think I'm going to leave this video here. And if you enjoyed this video, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and become a Patreon member for as little as $1 a month. It'll be great to get more Patreons, guys. Anyway, this is Astro30 saying see ya. Have a great day. And before I go, if you want to order this PCB, it's available on PCBway, and there'll be a link in the description also to how you can go about ordering them. I might sell a couple of these boards on eBay, see how I go. Anyhow, that's it. Have a great day.